Hello everyone, welcome to Clean Copper Talks. We are back again with another informative video on nanotechnology, which can be an affordable and scalable technology for water purification. So let's begin Clean Copper Talks. The problem of water contamination in India is huge. You can find heavy metals, you can find pesticides, you can find pathogens, antibiotics, microplastics, emerging contaminants, a lot of different type of contaminants in drinking water. Unavailability of or the lack of access to clean drinking water is a major issue, major problem which a rural population in India is facing today. And water is such a basic requirement, that it should be available easily to everyone. At least the as per standards, approximately 135 liters per capita per day of water is must. But today we see, especially in the rural areas, the water contamination problem is big, and a lot of different contaminants are found. So we need some solution. There are different technologies which can be used to clean a water, especially a drinking water, and to remove the desired contaminants from water, such as nanotechnology, reverse osmosis, filtration, uh, ozonation, UV disinfection, and many more. Today, in this video, we will talk about nanotechnology, how this technology can be applied to treat or remove undesired contaminants from drinking water or water. So, what is a nanotechnology? Nanotechnology is the application of science engineering in which a material at nanoscale, you between 10 to 100 nanometers, is used, and a lot of physical, chemical, or biological properties evolve as a result of surface phenomena, because of a huge surface area which is offered by nanomaterials. It has high surface area, high reactivity, high adsorption capacity, and many more which a nanomaterial offers, which can be used to harness its uh, properties to fight against the desired challenge. So, how nanomaterials remove contaminants? There, as I told you, there are different type of contaminants such as heavy metals, pesticides, pathogens, antibiotics, pharmaceuticals, personal care products, micropollutants, and many more emerging contaminants today can be found in very small quantity, trace level, microgram per liter to nanogram per liter, in even in treated drinking water, and not just in India but around the globe. There are research articles throughout the world, even in the developed countries, where such emerging contaminants, let's say antibiotics or pharmaceuticals or microplastics, or the conventional or parameters, or the heavy metals such as lead or arsenic, pesticides, are found in very small quantity. The problem with them is they are deleterious to human health even in very small quantities such as microgram per liter to nanogram per liter. Therefore, their removal is very important, and how nanomaterials do it is by two processes. First is the direct process which a nanomaterial offers is a adsorption. Nanomaterials offer a wide, huge surface area which can be used to adsorb such contaminants on its surface area. There are different physical and chemical phenomena which goes on as a surface as a contaminant adsorbs onto a surface of particular nanomaterial. Then the indirect effect which nanomaterial can apply to remove a contaminant is on the adsorbed contaminant by using photocatalysis or filtration process. Filtration means it will limit or it will not allow that particular contaminant to pass through that membrane, and photocatalysis is by producing hydroxyl radicals or superoxides which will oxidize the contaminants which is adsorbed over the surface of that nanomaterial. So, in this way, a nanomaterial can remove contaminants such as lead, arsenic, pesticides, antibiotics, pharmaceuticals, and personal care products, pathogens from water or uh, drinking water. Now, you will say that nanofiltration is how different than a conventional or traditional filtration. So, I'll let you know some of the parameters on which a traditional filtration can be compared to nanofiltration. So, the first is a traditional filtration is a physical or chemical process, such as sand filters, activated carbon, or sedimentation processes, while nanofiltration is a membrane based filtration. Therefore, water has to pass through a membrane, and it will that membrane will decide whether to allow or not to allow a particular contaminant to pass through it. The pore size in a traditional filtration ranges between micrometer to millimeter, while in nanofiltration it ranges between 1 to 100 nanometers. The mechanism in a traditional filtration is sieving, adsorption, gravity settling, while in a nanofiltration it is a pressure driven process through a semi permeable membrane. The contaminants which are removed in a traditional filtration are usually large particles, some selected bacteria, and limited organic compounds. Whereas in a nanofiltration, dissolved salts, heavy metals, small organic compounds, and even microbes are removed. The efficiency of a traditional filtration is 50 to 90%, while that for a nanofiltration ranges between 90 to 99%. The operating pressure required in a traditional filtration is zero point 0.1 to 1 bar, while that required in a nanofiltration is 5 to 20 bar. The energy requirement in traditional filtration is low, while it is high in nanofiltration due to the pressure requirements. However, the energy required in nanofiltration is much less compared to a reverse osmosis process. Water recovery in a traditional filtration ranges between 90 to 95%, while that in a nanofiltration ranges between 70 to 90% because some part of water is rejected. Then the maintenance required in a traditional filtration is between months and years, while nanofiltration you can leave it for 3 to 7 years and then maintenance will be required. The cost is for traditional filtration is low and for nanofiltration is much higher. Therefore, this is how a nanofiltration differs from a traditional filtration, but it offers a wide range of contaminant removal, even for the small microbes and bacteria and even small organic materials. Now, there are a lot of research articles around the globe, not just in India, which focuses on nanofiltration as or a nanomaterial uh, as a process to remove desired contaminant, such as this article written by Sanjeev and others is based on zero valent iron based arsenic filter. This filter removes the arsenic to desired drinking water norms, which is 10 microgram per liter, from 60 to 400 microgram per liter to 10 microgram per liter, and it has successfully removed it at a flow rate of 600 liters per hour. Therefore, this filters developed by IIT Bombay research group is can successfully provide water to 200 families per day. This article, written by Vidhu Sharma and research group, is based on integrated adsorption and membrane filtration for antibiotic removal. In their research, they have found that two antibiotics be effectively removed using their integrated novel integrated adsorption and membrane filtration. The initial concentration of norfloxacin and ofloxacin were 10 mg per liter, and they could achieve a removal efficiency of 98% and 94% for norfloxacin and ofloxacin respectively. Another research work published by Roy and research group is based on polymeric membrane using silver nanoparticles decorated functionalized carbon nanotube for mobile water purification, and they have also successfully treated water uh, effectively. So there are a lot of research which has already been done, not just in India but around the globe, for harnessing nanomaterials as a nanofilter to treat water and remove desired contaminant from the water. Uh, there are water kiosks also which use nanofilters to remove and treat water. Then, around the globe, South Africa has many nanotechnology enabled water purification units which are portable. The developing countries such as Bangladesh also has nanofilters which are able to combat arsenic poisoning. The region of Bangladesh and West Bengal in India is facing problem of arsenic contamination in groundwater since quite some time, since some years, and therefore nanofiltration acts as a very effective tool to remove arsenic from the groundwater. Then there are carbon nanotube based municipal treatment plants in USA. So the application of nanofilters throughout the globe has been widely applied to treat drinking water and even in some cases the wastewater and remove the desired contaminants. From affordability and scalability point of view, when nanofilters are compared to UV or RO treatment as a water treatment technology, then uh, if we see the cost comparison, then for a water treatment plant which has a capacity of 2000 meter cube per day of treating water of 2000 meter cube per day capacity, a nanofiltration plant will require $1 million, while a UV plant will require $200,000 and RO plant will require approximately $2 million. The operation cost again is very high for RO, then it is for nanofiltration, and then it is very less for the UV treatment. The water recovered in nanofiltration is 80 to 90%. In UV it is 100% because there is no membrane, there is no rejection, and in RO it is 50 to 80%. While the maintenance required for nanofiltration ranges between 3 to 7 years, in UV treatment it is every year, and in RO it is 3 to 5 years. So we can see that RO is much expensive. It rejects a lot of volume of water and it requires a lot of maintenance also. While nanofiltration is comparatively cheaper, it rejects less water and and it requires maintenance in comparatively less time. While UV is the cheapest, but it requires maintenance regularly, at least every month. Now, the government needs to step ahead to uh, promote nanotechnology as an option for drinking water, for effectively removing desired contaminants from drinking water. Now, this has to be case to case because a particular contaminant will be found in a particular region. Let's say in the West Bengal area we have arsenic pollution. Likewise, you can find pesticides pollution in region surrounding Haryana or Maharashtra. So the nanofiltration has to be designed in such a way that it is able to remove that desired contaminant. Now the government has also launched Jal Jeevan Mission, which aims to provide water to every rural household by 2024. I have already created a updated video on Jal Jeevan Mission as of 2025 because the aim was to provide rural water to every household by 2024. However, this has not been done so far yet. So what is the today's status of Jal Jeevan Mission as of 2025? A complete video has been already created by me. You can see its link in the description or in the I button above. Now, there has to be integrate nanotechnology in the treatment plant, in the complete water treatment plant. We have to ensure, or the government agencies or the authority have to ensure that nanotechnology is integrated well with the other treatment techniques of water treatment plant or wastewater treatment plant, so that we can harness the advantage of a nanotechnology to treat or remove the desired contaminants. Then a lot of funding is required, training is required to the personals, and R&D initiatives have to be taken from the government side or the public-private partnerships, so that much more results can be taken out, and a field application of this technology can be taken to another level, can be excelled, and very good results in removal of the desired contaminants from water can be achieved. Now, what are the challenges and limitations in application of nanotechnology for removing contaminants from water? Is the awareness and education. Awareness has to be brought to the people, especially those in rural area, and education has to be transferred, that how, what is the advantage of nanotechnology, what uh, features it offer, and how it can treat different contaminants from the water, even at the trace level, in the range of microgram per liter to nanogram per liter, it is able to remove. Therefore, this education, this awareness has to be spread among the people. A supply chain and production of nanomaterial is another limitation, because the specific nanomaterial, the demand for nanomaterial will increase rapidly as and when the awareness of its capability goes to the people. But thus there is a limited supply chain and production of nanomaterials. Therefore, the production capacity of nanomaterial has to be increased. Safe disposal of the nanomaterial, because if we use membrane technology, the membrane gets fold. The folding of membrane is a frequent problem which we face in any membrane based process, especially nano filtration membranes. Therefore, safe disposal techniques, safe disposal norms have to be set up of such membranes, because those membranes will have uh, contaminants absorbed on it, and that can further pose as a challenge, as a threat to human health or the environment. Therefore, safe disposal norm for such uh, membranes has to be found out, and then there has to increase the capacity of testing and regulations of the water at each level, at not just at the metro cities, but even in the district, even in the talukas, even in the villages. We need to have testing centers of water, so that we will know that the particular treatment facility is able to treat water to the desired level. What is the future outlook? What is the trends? See that green nanotechnology has to be developed, bio nanomaterials have to be developed, the researchers have to find out such materials which get degraded by themselves after its lifespan, after its full use. Combining of AI or Internet of Things with nanotechnology can help in real-time monitoring of the status of how the water uh, is, what are the different parameters in the water, and if the desired contaminant has been removed to the desired level or not. If we are able to integrate AI or Internet of Things into the real-time monitoring of water being treated from a particular nanotechnology based membrane, then it will be a very a big help and a step ahead in the field of science. Then there are startups and innovation opportunities, because this is a research gap. Integrating AI and Internet of Things to a membrane-based process. Uh, this is not yet there. So startups and innovation centers can see a big opportunity here. If any startup or innovation center is able to develop such a technology, it will be a market breaker. It will be a very super product, and therefore a lot of opportunity lies behind combining AI and Internet of Things to the real-time monitoring of contaminant removal through nanotechnology-based membranes. We can see how the water changes after it is filtered from a nanofilter and how it is before. So there is even wide difference just in the physical appearance of the water, and not just the physical appearance of the water. If we go for the water quality analysis, all the parameters can be seen as widely different from what it was before it was treated through nano filters. So we need local conservation to support such technology. And if you find this video is informative enough to reach to the local people, then please do share so that people get aware about the nanotechnology and it can be used at even at the local level. Encourage the community purification efforts so that you don't need any government to come and treat your water, but we can treat our water with the portable nanofiltration based technologies. These are the references used to prepare this video. And if my videos are adding any information to you, if my videos are of any advantage to you or of any help to you, then I request you to please like the video, comment down if you want me to make video on any another topic, and please subscribe to the channel. It will help me, it boosts my morale to make more such videos, more such informative videos for you all.